In this question it is given that the shortest distance between the lines this and this is, you have to find the correct choice. Note that if two lines are there in symmetrical form, that is x minus x1 upon a1, y minus y1 upon b1, z minus z1 upon c1, and second line x minus x2 upon a2, y minus y2 upon b2, z minus z2 upon c2. If the two lines are in symmetrical form, then to find the shortest distance between the two lines, remember the formula: determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 upon under root. First term will be cofactor of x2 minus x1, that is b1 c2 minus b2 c1 square, plus cofactor of y2 minus y1, that is a2 c1 minus a1 c2 whole square, plus cofactor of z2 minus z1, that is a1 b2 minus a2 b1 whole square. And mod should also be taken because the numerator may be negative also, and distance is always positive. Note that this is a formula if both the lines are in symmetrical form. If one line is in symmetrical form, other line is in unsymmetrical form, agreed, in that case we can do in this way that the line which is in unsymmetrical form, bring the unsymmetrical form to symmetrical form and use this formula, but this will be very lengthy. You must know directly the way of finding the shortest distance between two lines if one line is in symmetrical form and other line is in unsymmetrical form. And if both the lines are in unsymmetrical form, then also you must know directly how to find the shortest distance in that case, because converting unsymmetrical form of line to symmetrical form is lengthy procedure. Therefore it is never recommended to find the shortest distance using this formula, that is, I mean to say, converting the unsymmetrical form to symmetrical form and then finding the shortest distance. And for the other two cases, if you want to learn, you will have to see my video lecture of 3D for JEE level. Here, first of all, I will write this equation of line in symmetrical form. For this, I can write it as x plus 1 upon 1, y upon 1 by 2, z upon minus 1 by 12. First of all, make this line convenient to use. For this, multiply all the three denominators by 12. I get x plus 1 by 12, y upon 6, z upon minus 1. And second line is x equal to y plus 2 equal to 6 into z minus 1. That is, it can be written as x upon 1, y plus 2 upon 1, z minus 1 upon 1 by 6. That is, it becomes x upon 6, y plus 2 upon 6, z minus 1 upon 1, because this equation is more convenient to use as compared to this. And in this equation, x1, y1, z1 are -1, 0, 0, and in this x2, y2, z2 are 0, -2 and 1. And it is also clear that these are a1, b1, c1 and these are a2, b2, c2. Therefore, shortest distance is given by the formula 0 minus -1, -2 -0, 1 minus 0, and 12, 6, -1, 6, 6 and 1 upon, now cofactor of this is 6 plus 6 whole square. Cofactor of this is -6 -12 whole square plus cofactor of this 72 minus 36 whole square. First of all, let us calculate the numerator. This is 1, 12, 6 -2, 6, 6, 1, -1, 1. And now use a property that R1 changes to R1 plus R2 and R3 changes to R3 plus R2. I get 13, 4, 0, 12, 6, -1, 18, 12, 0. This is equal to 13 into 12 minus 18 into 4. Taking 4 common, I get 39 minus 18. That is 4 into 21, that is 84. And now denominator is equal to under root 12 square plus 18 square plus 36 square. Taking 6 square common, I get 2 square, 3 square, 6 square. That is 6 under root 4 plus 9 plus 36. That is 6 into 7. And because the value of numerator was 84 and value of denominator we have found is 6 into 7. Therefore, using this formula, I get shortest distance equal to 84 upon 6 into 7. That is equal to 2. Hence, I can say first choice is the correct choice.